long before dinosaurs ever walked the Earth, life had already begun. The ancient rocks of Greenland reveal this truth. Research conducted in the 21st century uncovered traces of organisms that lived nearly 3.8 billion years ago. These traces belonged to primitive single-celled microbes that lived in ancient oceans. They looked insignificant, yet they triggered the greatest transformation in Earth's history. By using gases such as carbon dioxide, methane, and nitrogen, they began producing the first oxygen. And in that moment, the fate of the planet changed. For nearly 2.8 billion years, oxygen-producing microorganisms slowly built the ozone layer. This protective shield made it possible, between 1 billion and 700 million years ago, for single-celled life to evolve into multicellular organisms. And finally, between 550 and 450 million years ago, the Cambrian explosion filled the oceans with unprecedented and bizarre life forms. Fossils found in the Orsten deposits of Sweden reveal that a 1.5 millimeter long arthropod called Cambra pachycope possessed a single compound eye made of thousands of lenses. This three-layered eye could filter light and provided a remarkably advanced visual system. This eye structure suggests it may have been a small predator. Some researchers also believe Cambra pachycope could be among the earliest members of the Pancrustacea lineage, using the tiny limbs beneath its body for swimming and maneuvering. But the strange creatures of the Cambrian were, of course, far from limited to this. During this period lived a bizarre creature known by its nickname, the Tully monster, measuring about 30 to 35 centimeters. At first glance, it resembled a leech. Yet studies suggest it may have been a vertebrate, and some scientists even believe Tullimonstrum could be among the first vertebrates on Earth. What truly set it apart was its long trunk-like appendage ending in a claw-shaped mouth. Tully spent its days searching for prey along muddy seafloors. When it found a target, it tore it apart using needle-sharp teeth inside its mouth. It also had stalked, droplet-shaped eyes that could move in different directions, much like a snail. Among the most unusual life forms of the Cambrian was Hallucigenia. Its worm-like body was covered with long, sharp spines, believed to protect it from attacks above. It moved along the ocean floor using small clawed legs beneath its body. Evidence suggests its eyes were poorly developed, forcing it to rely on long tentacles at the front of its body to navigate. The simple-looking mouth structure suggests that Hallucigenia was not a predator, but a bottom-dwelling feeder. Specimens reaching about 35 millimeters have been discovered primarily in China and Canada. Seeing these creatures, one might think life in the Cambrian was generally small, and that would largely be correct. Complex organisms were only just beginning to appear. Most species were far smaller than their modern descendants. Yet, despite this, true giants also existed. Omnidens occupied one of the highest levels of the food chain in Cambrian seas. Though its exact size is unknown, fossilized mouthparts suggest it reached 1.5 to 2 meters in length. Two massive appendages near its mouth guided prey into its circular feeding structure. Its body was composed of repeated lateral swimming lobes rather than true walking legs, and it likely fed on other marine animals. All evidence points to Omnidens being one of the top predators of the Cambrian oceans. Another massive hunter was Anomalocaris, whose name means abnormal shrimp. It is regarded as the largest shrimp-like creature ever to live. Between 550 and 520 million years ago, it ruled the seas alongside Omnidens. But Anomalocaris possessed a unique distinction. It may have been the first true predator in Earth's history. Fossil evidence shows it had stalked compound eyes made of thousands of lenses, capable of detecting even the slightest movement in water. Its undulating swimming style gave it exceptional speed. With sharp vision, an agile body, and powerful grasping limbs, it was a master hunter. We know how it attacked from V-shaped bite marks left on trilobite fossils. Despite its fearsome abilities, Anomalocaris was smaller than Omnidens, reaching no more than 1 meter in length. Not all Cambrian creatures were predators. Some avoided competition and fed on free-floating nutrients. Egirocassis was the giant filter feeder of the Cambrian. One of the largest and most advanced organisms of its time, it filtered seawater much like modern whales. Hundreds of fine spines formed filtration structures that continuously extracted plankton. This efficient feeding method allowed it to exceed 2 meters in length while consuming minimal energy. Thus, it earned the title of the largest arthropod ever to live. And this reminds us of something fundamental. Nature repeats effective strategies across millions of years. Just like whales, large bodies, low energy cost, and efficient filter feeding. Helicoplaccus was an early echinoderm related to the ancestors of sea stars and sea urchins, living around 530 million years ago. Its small, spiral-shaped body measured only a few centimeters. A short basal structure may have helped stabilize it on the seafloor. Its mouth was located at the top of the body, likely drawing in seawater to capture microscopic food particles. Balutocaris was among the largest and most complex arthropods of the Cambrian, living around 506 million years ago and reaching up to 25 centimeters in length. With a highly segmented body and well-developed eyes, it was an active swimmer that likely moved continuously through the water column, and its size may have protected it from most predators. While its exact diet remains uncertain, it possibly fed on organic matter or carcasses drifting along the seafloor. Fascivermis, which lived around 518 million years ago, displayed a highly distinctive body structure. Its soft, elongated, worm-like body was divided into 3 main regions, giving it a flexible yet specialized appearance suited to life on the Cambrian seafloor. The anterior section carried several slender appendages that extended forward into the water, while the long middle region housed vital organs and formed the core of the body. The posterior end was swollen and pear-shaped, bearing rows of small hooks around the digestive opening, likely used to anchor the animal firmly to the sediment. Anchored in place, Fascivermis may have raised its front appendages to capture small organisms or drifting organic material, although its exact feeding behavior remains uncertain. Fascivermis was just one of thousands of remarkable Cambrian creatures, but like so many others, it was shaped by a great transformation in Earth's history. Around 488 million years ago, an unknown event wiped out a large portion of Cambrian life. We still do not know exactly what caused it. Some hypotheses point to declining oxygen levels in the oceans, a global ice age, or massive volcanic activity. The Cambrian came to an end. But the story had only just begun.